Snag it is what it's called. Yep, it says recording right now.
Hey, Colin. Hey, Colin.
Yo. What's up?
You guys are funny. Okay. So what we're doing today is making the connection between electron configurations and the periodic table and how it's organized and how it's arranged. And once you learn how to read the configurations just by looking at where the elements are on the periodic table, you'll probably be able to do this a lot faster. You might not have noticed, but then again, you might have noticed whenever I'm trying to do a configuration, like when I'm trying to do examples for you guys up here, I'll stop and I'll look, and I'll be counting to see where it is. What row is it in? How far over is it? And that tells me, because I know how to read the periodic table for that, that tells me what the configuration is going to end in. And then once I know that, I know I just have to fill up all the electrons before I get to that point. So it can potentially make things a lot faster for you. So we're going to start with this funny looking periodic table here and just a regular pen or pencil. And there's probably a couple differences that you see on this periodic table compared to our normal one. So how is this different? Ryan?
The normal one usually takes out the two middle columns, the rows.
Yeah, right here, these usually aren't there. They're usually at the bottom. And the reason for that is just as simple as the size of the piece of paper that we have. If you look at these boxes on your piece of paper, and you look at all the information that's on a normal periodic table, probably isn't going to fit in these boxes. So just as simple as the fact that our piece of paper is 8.5 by 11, and we can't get all that information in there, we pull those last two rows out and put them at the bottom. Chris, do you see another difference?
The top of the left-hand side, there's two boxes.
Yeah, there's two boxes right here, and normally on ours there's just one for hydrogen. So we're actually going to start by taking your pen or pencil, and we're going to go ahead and fill in that box. Right there, we've got an extra box. And we'll talk about why that's there in just a minute. But we're not actually going to use it for anything, so we'll just go ahead and fill it in. So, to make the connection between electron configurations and the periodic table, we'll start by putting the end of each element's electron configuration in the boxes. Boxes are a little bit small, so you might have to write a little smaller than normal, or you could always kind of write sideways in the box if you need to. But we'll start with the simplest element up here in the left corner, which is hydrogen, which has how many electrons? One. So hydrogen's electron configuration would be 1s1. So that's what we're going to try to put in this box. 1s1. What's the next element? Helium, which has 2 electrons. What would its configuration be? 1s2. So over here where helium is, we'll put 1s2. Lithium would be next, and if we were going to list its whole configuration, we would say 1s2 and then 2s1. So we'll put the 2s1 where lithium is. Beryllium would be next.
2s2.
It would end with 2s2. Some of you are probably already seeing the pattern just from doing this first row. How many electrons can an S hold? 2. How many boxes go across in that section? 2. That's convenient, isn't it? Oh, and well, we haven't got that far yet. Hang on to that one. Okay, so let's go. Let's see, we did beryllium. What would be next? Boron, which would end with 2p1. And then we would have carbon, which would end with, what's next? 2p2. And then nitrogen, which would end with 2p3. And then 2p4 for oxygen. 2p5. It's a little harder to read up here. What's the last one going to be? 2p6. How many electrons can you put in the p sublevel? 6. How many boxes go across right there? 6. Isn't that convenient? Makes sense. And now, kind of just like a computer or like a typewriter, you hit all the way to the end of the row, hit return, go back and start on the next row. So the next one would be ending in 3s1 and 3s2. What comes after 3s2? 3p1 through, what would the last one over here be? 3p6. And you can go ahead and write those in if you want. Mine's getting a little crowded up there. So 3p1 through 3p6. And then, here's what's even better about using this method. You no longer have to remember where things go out of order, because the periodic table tells you where things go out of order. Go to the end of the 3p6, hit return, go back to the next line, and what do you think that should end with? 4s1 and 4s2. And now, you're going straight across, read it like a book, left to right. Now we've got a new section here in the middle. What do you suppose that's for?
The D.
The D. What's the first energy level where we have a D? 3. So this is going to be 3d1. How many electrons can we put in a D? 10. How many boxes go across in that little section there? 10. Look at that. So this ends with, I'm going to turn this one sideways so I can fit it in, 3d10. And in the middle, you would have numbers 1 all the way up to 10. What would come after 3d10? Look at the pattern. 4p. 4p1 through 4p6. What would come next? 1, 2, 3, 4, 5. And that was the other pattern that Brandon was noticing earlier, was that every row you move down in the periodic table goes 1, 2, 3, 4, 5. Except for the middle. You gotta watch out for that one, and you kind of just have to know that that starts with the 3D. So we'd have 5s1 and 5s2. And then middle section right under the 3D, that would be 4D. 4D1 all the way through 4D10. What would be under the 4P? 5P. I think some of you may have already filled these in. Kind of looks like you're working ahead. 5P6. After 5P6? 6s1 and 2. And now we have another block in here. What's this block for? The F block. How many elements go across in the F block? 14. How many electrons will the F hold? 14. Now you have to know, what level does the F start with? 4. That's the first time that you see the F. So this is going to be 4F1 all the way through to 4F14. Do you need time to write it down?
Yeah.
Mm-hmm. So if you watch me do electron configurations, I'll look at the periodic table. I will decide how many rows down is it, what block is it in, and how many spaces over in that block.
Is that why, though, the lanthanide and the actinide series are usually depicted below?
That really has more to do with the paper size and the fact that you can't fit as much stuff into those boxes if you make them that small. In fact, if you are a little bit ahead with your labeling, this piece of paper has 2 lines on it for a reason, so that you can fold it this way. And take this edge and fold it this way. And there's your normal periodic table that you're used to seeing. This is the long version. That's what you're used to. Little origami lesson. Okay, so let's fill the rest of this out real quick. We've got 5D1 through 10. Then we would have 6P1 through 6. Then we would have 7S1. That's kind of messy. 7S2. 5F1 through 5F14. 6D1 through 6D10. And then 7P1 through 7P6. Yeah, you just have to remember this is the 4S and then you start the 3D. So there are a couple of things on here that you have to memorize, and I think it actually helps a lot, even with knowing there's 10 electrons in the D sublevel, because there's 10 things that go across there. So if you just count the number of boxes there are, then you know how many electrons there are in that sublevel. What we're going to do next is color on your normal looking periodic tables. We're going to try to do 2 of them.
I'm not done yet.
Okay. While we are waiting for people to finish up, what we're going to try to do with these, we're going to color one according to the sub-levels. So according to the different blocks of elements, we'll have an S block, P block, D block. And then the other one, we're going to try to color according to energy levels, 1, 2, 3, 4, up through 7. Probably, we are going to need you to, if you want, shade in your periodic tables later. So what I'm going to do on the smartboard is just outline things in colors. And you will probably need to do that on your periodic table as well. If you choose to go back and shade things in later, you're certainly welcome to do that. We're probably not going to have time for everybody to color 2 entire periodic tables in class today. But you're not getting any other homework today, so if you want to finish coloring them later, that's certainly your choice.
So we don't really have to like put all the numbers in between them?
No, you don't have to put all the numbers in between. Okay, so it looks like we are close to ready anyways. And gotta find the periodic table that we need. I'd never find anything otherwise. Okay, so here's our periodic table. And the first one that we're going to color is according to the blocks of elements. So if you had to point out where are all of the S elements, what would you say?
Column 1, column 2.
Yeah, column 1, column 2, everything on the left-hand side. So pick one color, and we're going to outline these. Except
for helium in there too.
yeah, helium's in there too. So if we were just going to put helium on the periodic table, according to its electron configuration, what spot would it go in?
Above beryllium.
Above beryllium, here where we colored that other box out. So if we put it on there according to electron configurations, that was where it would be. Why do you suppose it's all the way on the other side though?
Because it's a noble gas.
Because it is a noble gas, and we also try to put elements together according to their families. Helium is very much like the elements that are underneath it: neon, argon, krypton, xenon, and radon. So instead of putting it here with the S block, we put it on the other side with the noble gases. And that is, in fact, what this area is labeled the S block elements, including helium on the other side. Where's the P block? Right side. Everything that fits into this area where the periodic table goes 6 elements across. Now remember, I'm not waiting for you to shade in your periodic tables. We're just outlining. You can shade them in later. Where's the D block? In the middle. Everything in the section where it goes 10 across. And the F block, only thing left, down at the bottom. And on this periodic table, you can see that they've left a space in the center for where these elements would go if we had room to put them, right there. Not all periodic tables have that space built in there. So you can see where the F block elements would go. Oops, should label this F block. Once you've got your stuff outlined, then we're going to flip over to the other periodic table. Told you I wasn't waiting for you to shade in, so we're going on. Well, you're just outlining, and I'll wait a minute for you to do that. The next one we're going to color by energy levels. So here's where you'll need your 7 colors, because we have 7 energy levels. I will have to recycle my colors up here on the smartboard since I only have 4 colors.
Could you do like a combination of 2 colors?
I think that might get a little complicated. Okay, so here we go, energy levels. Where is energy level 1 located? At the top. It includes hydrogen and helium. And that is energy level 1. Where's energy level 2? I hope we know it's the second row. You should, off of your other periodic table. And if we don't end up finishing in class today, you can use the one with the little boxes where we filled out all of the different levels. You could use that to help color code this. Then we'll do energy level 3. There's 2 places where you expect to have it. Where else do we have energy level 3? In the D block, the very first row of the D block. Then we have energy level 4. We'll do the 2 places where you expect to find it. And then it also gets a row in the D block. And it gets one other row. Where else does it have a row? The F block. So the first row of the F block is also a 4. Now I'm going to have to recycle colors for row 5. Then we have energy level 6. Oops, what did I forget? F5. The 5F, we should say. Okay, now we can go on with 6. And last one, 7. Now again, if you want to finish coloring these, that's certainly up to you. There is no other homework tonight.